Alright, so I want you to take a second. Now this is a mixture of different ones. We've got ionics and covalents here. Take a second and pause the video and do these 8 right now. These are ionics and covalents mixed together. This is where it gets hard. You have to identify them first. Pause the video, do it. We'll come back. Okay, we're back. Now what we're going to do here first is start with NO2. The question we ask ourselves first is to decide whether or not this is an ionic compound or a covalent compound. Does it have a metal in it? Nitrogen, nonmetal. Oxygen, nonmetal. This is a covalent compound, that means. So what we're going to do is name it with the covalent system, where we are just simply going to say nitrogen, and there's 2 oxygens, so we say dioxide. We don't use mono for the nitrogen because we never use mono for the first thing. The next one, ask ourselves the question, is there a metal in here? Yes, sodium is a metal. So now we have to name it using the ionic system. Sodium. Then we ask ourselves the question, does sodium form more than one kind of ion? The answer is no. If you need to learn about ionic naming, you should go back and watch that tutorial. Sodium always forms +1 charged ions. It's in that first family. They always do +1s. NO2 is the polyatomic ion nitrite. So we have sodium nitrite. The next one, do we have a metal in here? You bet we do. Copper is a metal. And copper is one of those metals that has got more than one kind of ion that it forms. So we need to leave some parentheses in there to tell what is the charge on this particular copper. And it's paired up with chlorine, which will be changed to chloride for this compound. Now, what's the charge on that copper? All right, there's 2 chlorines here. 1, 2. Together, those 2 chlorines would have a charge of -2. But there's only 1 copper. In order to get a charge that's balanced out for an ionic compound, we have to have a copper with a +2 charge, so this must be copper with a 2. Make sure I make that clear. That should be a Roman numeral 2 chloride. Copper 2 chloride. All right. Next one. Do we have a metal here? That will decide whether we have ionic or covalent compound. There is no metals here. Sulfur is a nonmetal, so is chlorine. So we're going to use the covalent naming, the easy naming system. Sulfur and then hexa chloride. Because there's no metals, this is a covalent compound, and we name it using prefixes, and it's really super easy. Now this next guy is tricky. Just regular fluorine. Just fluorine. Just F. Remember from when we talked about in class the diatomic atoms. There are 7 nonmetals that when they are all by themselves will always buddy up. Fluorine is one of them. So fluorine's formula is F2. It is a diatomic, 2 atoms put together. The diatomic 7 starts at element number 7, which is nitrogen. Looks like a number 7 on the periodic table. It goes across and down just like a 7 does. And then also includes hydrogen. So there are 7 total elements that do that always buddy up. So if we have fluorine by itself, it's F2. All right, calcium and carbonate. Calcium is going to be, let's see here, it's a metal. So we are going to have to think about this like an ionic compound. Calcium forms +2 charged ions. Carbonate is a polyatomic ion with -2 charge. +2 and -2 would go together beautifully. We want one of each of them, calcium carbonate. Phosphorus triiodide. Look at that, I see this prefix right here, this tri. That's a dead giveaway that I'm talking about a covalent compound here. So there's just 1 phosphorus given there, and triiodide means that I want 3 iodines. And finally, we're working on manganese sulfide. Manganese is a metal, and it's got more than one kind of charge. That's what this Roman numeral is all about. This ionic compound has got manganese the metal with a +4 charge. That Roman numeral tells me that that charge is +4. And it's with sulfides. Sulfides are always -2 in ionic compounds. And so we've got a +4 and a -2. We'll take 2 sulfides together to get -4 and balance out the manganese as +4. Manganese sulfide looks like that. Here's another set for us to work on. Starting off with the very first one. Pause the video and come back and we'll do it together. The very first one is element, or rather a compound that you probably know already. It's got no metals in it. Carbon and oxygen are both nonmetals. So we have got a covalent compound that will be named using prefixes carbon dioxide. Dioxide for 2 oxygens. It's not monocarbon dioxide because we don't use mono on the first element. The next one. Do we have a metal here? Potassium is a metal. It's from the left side of the staircase. So potassium is going to indicate that this is an ionic compound. Potassium, and then I ask myself, hey, do I need a Roman numeral here? Potassium always forms +1 charges. It's in that first column, so no Roman numeral is necessary here. And we just have to look up what this polyatomic ion is. It turns out that it is permanganate. And that is on your green sheet. Potassium permanganate. Fun compound. All right. The next one here. Does it have a metal in it? Yes, it does. Iron. Does iron form more than one kind of charge? So back up here. It's got a metal in it, so it's an ionic compound. And we're talking about charges again now. Iron forms more than one kind of ion, so I need to say which one it is with a Roman numeral, and it's paired up with this polyatomic ion. That is sulfate, and it can be found on your green sheet. Now, sulfates are individually -2, but there are 3 of them ganged up here, SO4, 3 times for a total of -6. If altogether those are -6, and we've got 2 irons over here, each of those irons must be the +3 variety, because then together they would be +6, and that's how we got this compound listed here. So the iron is the iron with a charge of +3. That's what our Roman numeral tells us. Then we get down to this next one. We have got phosphorus and oxygen, both of which are nonmetals. We have got a covalent compound here. So we're going to use the prefixes for this one. We have 2 phosphoruses. So we have diphosphorus. And then 4 oxygens would be tetraoxide. All right, now we're going the other way here. Sulfur trioxide. This tri right there gives a good hint to me that we have got a covalent compound. And the fact that it's sulfur and oxygen confirms it. There's no metals here. So we're just going to go sulfur trioxide. 1 sulfur and 3 oxygens. Calcium hydroxide is the next one. Calcium is a metal. It's from the left side of the periodic table. So we got to think ionic compounds and charges here. Calcium forms +2 ions. Hydroxide is a tricky one that many students often get confused on. It ends in IDE, which most people think that it means it comes from the periodic table because we changed those ions to end in IDE. And that's a decent thought. Hydroxide and cyanide are the 2 tricky polyatomic ions that end in IDE. This is polyatomic. It's on your green sheet. Hydroxide is OH. It's got a -1 charge. So we want 2 of them together to give us a -2 charge and pair it with the calcium, which got a +2 charge. Now this is also a little tricky to write. Students often make mistakes on this one. When I get this one a lot is that right there. That's no good. We want 2 of the whole hydroxide. It's important that we include the parentheses there to say we want 2 of that whole thing. In the next one, we've got potassium and phosphide. Potassium is a metal. Ionic compounds. Think in charges here. Potassium forms +1 charged ions. Phosphide, IDE, means phosphorus. Coming right off the periodic table, ending in IDE, which forms -3 charged ions always. Potassium phosphide is going to be 3 potassiums ganging up to form a +3 charge against the 1 phosphide. So potassium phosphide is that right there. And finally, carbon monoxide. We have got carbon, and this mono means that I probably have got a covalent compound here. Carbon and oxygen are both nonmetals. That confirms it. I'm just dealing with the easy system here. CO is carbon monoxide. So that's a couple of sets of practice now using the mixed naming system. Again, the biggest challenge here is to decide, is this ionic or is it covalent? Once you've got that decided, you just make sure that you keep your naming system separate and that you apply the right procedures, and away you go.